Okay, so we'll be talking about relations and functions, more specifically functions. We'll use the relations to explain or to start the functions. So, what is a relation? A relation is a link or an association between two different sets. Let's consider the statements. Kwesi Esiedu is the father of Ikea. The first set is KSED and the second one is Ikea. The relation between them is that this guy is the father of this. That is the relation between them. Let's also consider another one. For example, Mary is the sister of Mark. Mary is the sister of Mark. So the relation between Mary and Mark is that Mary is the sister of Mark. That is the association between them. What joins the two of them is their relation. And the relation here in this case is sister. This is the sister of that. That is basically what the relation is. So in maths, we can also have relations too for a set A and another set B. We can have set A containing 4, 6, 8, 10, and set B containing 20, 40, 60, 80, 100. The relationship between the two is what joins the two sets together. So 2 to 20, 4 to 40, 6 to 60, 8 to 80, and 10 to 100. This is 10, by the way. This is the relation. This whole thing is not a relation. This is the relation. The link between them is what we call the relation. Only this is the relation. The first set in a relation is called a domain. The first set is called a domain, and the second set is called a co-domain. So in the examples listed above, Mary would have been in the domain, and Mark would have been in the co-domain, and the relation that joins them would have been what links the domain to the co-domain. In that case, sister. Mathematically too, we can express relations in domain and codomain. So for example, listed above, domain would have been 2, 4, 6, 8, 10, and our codomain would have been 20, 40, 60, 80, 100, and this is the relation between them. There are several types of relations. We have number one, one-to-one relation. So if I have a set A and I have another set B, take note this is the domain and this is the co-domain. So if I have a set A containing the values 0, 1, 2, and I have another set B containing the values 0, 1, 2, 3, 4, 6, and each element in set A has exactly one element in set B. In other words, if every member of the domain has one element in the codomain, then the relation is said to be one-to-one. So in this case, we have something like this. Then this relation is said to be one-to-one. Every member in the domain has only one member in the codomain. That is a one-to-one relation. The second type is called a one-to-many relation. So similar to the one-to-one relation, if I have a set A and a set B, let's say A, B, C, D, and I have X, Y, Z, T, and a member in the domain has more than one element in the codomain, then the relation is said to be one-to-many. For example, if E maps to X and Y, this maps to this, and this maps to this, this is said to be a one-to-many relation. It's a one-to-many relation. The reason why it's a one-to-many relation is that one here has many elements here. There's a many-to-one relation. Similar to the predecessors, if I have a set A and a set B, let's say A, B, C, D, and P, Q, R, S, and more than one element in the domain have the same element in the codomain, then it's said to be many-to-one. For example, if A maps to P and B maps to T, C maps to Q, D maps to S. This is a many-to-one relation because many elements in the domain have the same element in the codomain. Many elements are mapped into one. It will still be true if another value will be A also mapped to Q. This will still be many-to-one. This will still be many-to-one. The last type is a many-to-many relation. A many-to-many relation. A many-to-many relation is when I have a set A and another set B, and many elements in A map onto many elements in B. A, B, C, D, E, P, Q, R, S, T, and I have something like this. This is a many-to-many relation because many elements here have many elements in this. This is a many-to-many relation. Classic example of many-to-many relation. The next thing we look at are mappings. So when we say a mapping is a relation in which the domain or many elements in the domain map onto only one member in the codomain. Mappings are relations in which a member in the domain maps onto only one member in the codomain. So from this definition, we can tell straightforward that a one-to-one relation is a mapping. Same way, a many-to-one relation is also a mapping. So a mapping is a relation that has only one member of the codomain attributed to one or several elements in the domain. Let me give you a graphical example. It's just the same as one-to-one and many-to-one. So we can have A, B, C, D, E, F, G, and H. This, or this. These are all mappings. What is not a mapping is a one-to-many relation or a many-to-many relation. Those are not mappings. So if I have something like this, it is not a relation. Something like this. This is not a mapping. Sorry, this is not a mapping. It's a relation, but it's not a mapping. This is a one-to-many relation, one-to-many, and it is not a mapping. then many-to-many relations are also not mappings. They are not mappings. So we can say all mappings are relations, but not all relations are mappings. From what we just realized, we can say that all relations are mappings, all relations are not mappings. All relations are not mappings, although all mappings are relations. The rule that mappings follow are called functions. So we are now on the main event, functions. The rule that all mappings follow is what we call function, the function. The function is the rule followed by a mapping. So if I have a set x and another set y, such that every member here has only one element, then this is a mapping. And then the rule that the mapping is using is called a function, written as f of x equals. So we'll be seeing this very much in further explanations. We'll be seeing this further. So what a function does is basically it's like a box and it converts the x value to the y value, having something like this. And maybe a value 2, you put 2 inside and get an outcome of maybe 16. What this box is doing is that it is converting R2 and giving us 16 by a certain rule. This is the function. And then the rule it's operating by is that the x value should be raised to a fourth exponent to give us the y value here. And then this is called a function. By definition, and from what we've done so far, we can tell that all functions are either one-to-one or many-to-one. That means that a one-to-many relation is not a function, and a many-to-many relation. So we can have an example of functions f of x equals x squared plus 7, f of x equals e to the power x, f of x equals cosine of x plus 14 e to the power x. We can have f of x equals 2. These are all functions, rules that relate an x value to f of x, we call a functional value or our y value. Now, for most questions, we will not be given the domain or the codomain. We will rather be given the rule or the function itself. For example, f of x equals x squared minus 2. With this, you can be asked to find the domain or the codomain. The domain is the set of values that you can plug into the function. Like the set of values here that you can feed into the function. That's the domain. Then the codomain is the set of values that the function can output. This is the codomain. The domain is what is plugged in, and the codomain is what it returns. So you can be given the rule for the function or the equation of the function, and you will be asked, or you can be asked to find the domain or the codomain. What we do now is that we investigate, you can see if all values of x will satisfy the function given. The only reason reason why a function will not output a value is if the value or the x value will result in the production of an imaginary number or a number that is not real. What do I mean by that? I mean, if you put a value, an x value, into a function, and the result given is not a real number, then that particular x value is not a member of the domain. What this means is that you investigate and see if the number you are putting into the function will result in a negative, an imaginary number or not. How do we get imaginary numbers? We get imaginary numbers when the denominator of a fraction is 0. So if I have a fraction a over b and b is equal to 0, then the fraction a over b is not real, or it is undefined, or it is imaginary. Also, if I have square roots of a negative number, say a, this always gives me a number that is not real, or imaginary, or undefined. Another way you can get an imaginary number is when we have log of 0. Log of 0 also gives me the same thing, an imaginary number or an undefined number. Basically, these are what we'll be using right now. And okay, then trig ratios too for trigonometry. When we have cos inverse of a number that is greater than 1, that also gives me an undefined number or an imaginary number, or sine inverse of a number greater than 1 or less than negative 1 for both of them. If cosine inverse of a number less than negative 1 is also plugged into the cosine inverse function, we get either one unreal number or an imaginary number. We use these rules here, 1, 2, 3, 4, 5, to help us in finding the domain of a function, any function at all. Let's list them correctly here. Let's list them. The first one is denominator being 0. The second one is square root of a negative number. So this is a number over 0. Square root of a negative number, square root of negative e. The third one is log of 0. The fourth one is cos inverse or sine inverse of a number greater than 1 or less than, greater than 1 or less than negative 1. These are the 4 things that we'll be dealing with. So, but primarily for functions or for the use of functions, for the sake of functions, we consider this and this in our dealings, the 1 and the 2. These ones, although gives you undefined values, you don't usually see them in dealing with functions as a topic. So focus mainly on the first 2. Let's use a question to try and find the domain of any number at all. Let's take a function f of x equals 3x minus 1 divided by x minus 3. We want to find the domain of this function. By default, the domain of every function at all is a set of all real numbers. A set R of all real numbers, meaning that x is always a member of all real numbers for the domain, written as this. But From our discussions, we realize that the function will have a number that is not part of the domain if that number produces an imaginary number. So what we do is that we investigate and see what value will produce an imaginary number and we exempt it from the function domain. The rules we listed, the first two rules over here, is when the denominator is 0 or when we have a square root of a negative number. For our function here, we don't see any square root here, so we just consider only the first one. When will the function have a denominator of 0? It will have a denominator being 0 if the denominator itself here is equated to 0. We can have an x value that produces 0. So you solve the equation x minus 3 equals 0 and you find the x value. This will give us x equals 3, meaning that if I were to put 3 inside the function like this, I'm going to get 8 over 0, which is an imaginary number. So 3 cannot be a member of the domain. So my domain is now written as this. Domain is now written as this. X is such that x is a member of all real numbers, but x is not equal to 3. X is not equal to 3. Simple. Let's take another question and see our understanding of the subject. We can have f of x equals 2x squared minus 4 all over x plus 1. The same thing, we equate that one to 0. X plus 1 equals 0. X equals negative 1. Meaning that our domain is x such that x is a member of all real numbers, but x is not equal to negative 1. Let's take another question and then we move on to the next thing. F of x equals 3x minus 4 over 2x minus 3. Again, we equate that one to 0. 2x minus 3 equals 0. We get 2x equals 3. Divide both sides by 2. And we have x equals 3 over 2. The domain in this case also becomes the domain x such that x is a member of all real numbers, but x is not equal to 3 over 2. Let's try this next question on our own. F of x equals 6x minus 4 all over 3x plus 5. You can pause the video and solve this question. When you finish and you compare the answer and see if you have the same answer. If you were able to do this, you realize that the domain is x such that x is a member of all numbers, but x is not equal to negative 5 over 3. Let's look at the next type, how the question usually comes, how the question usually appears in the next thing. We can have f of x being square root of 2x minus 1. This is a function, a square root function. Now, again, let me scroll back. We said that the function has an imaginary value if we have square roots of a negative number. Meaning that this function exists for all values except when x is a negative number. So we look at the values of x. Now we have to plug in the function to get a negative number. For that to be true, it means that 2x minus 1 will have to be less than 0 for you to get a negative number. 2x minus 1 will have to be less than 0. We solve this. divide both sides by 2, and our domain becomes f. Our domain becomes x such that x is a number of all numbers where except x less than 1 over 2. So number of all numbers except x is less than 1 over 2. So for the next example, we have f of x equals square root of 3x minus 2. Again, we look at the function and we see for which values will all the expression inside the radical sign be less than 0. So 3x minus 2 less than 0. Realize that 3x is less than 2. Divide both sides by 3. Get x less than 2 over 3. Meaning that for all values less than 2 over 3, the function will not exist. If I put 2 over 3 inside, I get 0. But if I put any value less than 2 over 3, I get any. So it means that the domain is that x is such that x is number of all numbers except x is less than 2 over 3. Yeah. Let's also try f of x equals square root of 1 minus x squared. For this to less than 0, we have 1 is less than x squared, or x squared is greater than 1. This is the same thing. I've just flipped the inequality. I find square root of both. This will give us a plus. This will give us a plus or a minus sign here. We have x greater than plus or minus 1. From solving linear inequalities, which then become x is less than negative 1 or x is greater than 1. This is our exception, meaning that the domain of x such that x is a number of all numbers except x is less than negative 1 or x is greater than 1. Let's try this question. F of x equals square root of x squared minus 4. Negative 2 less than x less than 2, so that the domain will be x such that x is a number of all numbers except in the interval negative 2 less than x less than 2. Let's move on to the next type of questions. You can have a combination of a fraction and a rationality or square root sign. You can have f of x equals square root of 2x minus 1 all over x minus 2. This one is more difficult. Solving this, you have to look at them one by one. You solve the denominator problem, then you solve the rationality problem. Let's take the top one first. So 2x minus 1 less than 0, x is less than 1 over 2. Then we take the down one and equate that to 0. Equate the denominators to 0. We get x as 2. So this means that our domain is set x such that x is the number of all numbers where x, except x is equal to 2 or x is less than 1 over 2. Let's try another question on that to get things clear. And have f of x equals square root of 2x minus 2 all over 3x plus 6. Solving this one by one, we get 2x minus 2 less than 0, x is less than 1. Then we have this part 3x plus 6 being equal to 0, x is equal to negative 6 over 3, x is equal to negative 2. You realize that negative 2 is already less than 1. So this is not necessary. You can just write this without writing this. So you have our domain being x such that x is a number of all real numbers where x is less than 1. Sorry, except x is less than. Without the except, you have to tell you wrong. Without the except, you have to tell you wrong. Let's try this question and then move on to another. Right, so let's try this. F of x equals square root of 5x plus 1 over 3x minus 7. You can pause the video at any time and solve this. Pause at any time and solve this and compare if your answer is correct. You get something like the numerator x such that x is a number of all real numbers except x is equal to 7 over 3 or in x less than negative 1 over 5. You should get something like this. You can also have the fraction added down. For example, f of x equals x all over square root of x minus 1. In this case, the denominator is the fraction. The denominator is, sorry, the root. The denominator is the root. And we are supposed to equate the denominator. We are supposed to also equate the expression inside the radical sign to less than 0. So in this case, what we combine the two so that what is down here in the expression x minus 1 should be less than 0 and it should not be equal to 0 too. So it should not be less than or equal to 0. We use it to solve less than or equal to, so that we solve this and get x is less than or equal to 1. So the domain is x such that x is a member of all real numbers x except x less than or equal to 1. Let's try another one. So in this case, the numerator is useless. We don't need it in our solving because the numerator will always give us a raw number, except when the numerator is also a set, or it also has a radical sign. You hardly get something like that, but you can also get something like this. F of x equals 3x plus 2 all over square root of x squared minus 9. You equate this, you use less than or equal to sign again. Now will be x squared minus 1 less than or equal to 0, x squared less than or equal to 9, x less than negative 3. So after finding square root of both sides, plus or minus negative 3. So that the domain will be x such that x is a number of all numbers except negative 3 less than or equal to x less than or equal to 3. As simple as that. You can solve the last question on your own. X equals 2x minus 1 all over square root of 4x squared minus 25. You can pause it and solve. After solving, you can compare with the answer. When you're done, you should get something like this. The domain of x such that x is a number of all numbers except when negative 5 on 2 is less than or equal to x less than or equal to 5 over 2.